Okay, so here's a question for you. Knowing the speed of sound at 0 degrees is 331 meters per second, find the wavelength of 1,000 hertz tone at 20 degrees and the wavelength of the same tone at 40 degrees. Which is why you now need to retune your instruments in a band. Anybody play band? Outside? Yeah? Do you have to retune when it gets really cold and really warm? Yeah, this is why. So what do you have to do? So we know speed equals lambda f. They give you a frequency of 1,000 hertz, and they're asking us to calculate lambda. But the speed changes, so the formula that we should be using is speed divided by f equals lambda. There is a small problem that speed changes at 20 degrees and speed changes at 40 degrees. So what formula should we use? The one we saw here? Okay, let's do this. So at 20 degrees, this would be what? 331 plus 0.606 times 20. And 331 plus 0.606 times 40.
Yeah, 343.12.
And then calculate it for the 40 degrees. That one I know. It'll be like 350 something. 355. There we go. Perfect. So then what will be the lambda for this case? And what will be the lambda for this case? Yes? 0.355. Do you see the difference? So if I look at this, think of it this way. This is lambda 1 is about 34.3 centimeters and lambda 2 is about 35.5 centimeters. That is a huge difference in terms of where the nodes and antinodes would exist. And this is the reason why you have to tune your instruments every time the temperature changes. So people in the band, everything goes back to physics. There is always a physics explanation for everything you do. Isn't that amazing? Like you can point to any physical phenomenon that exists on planet Earth and or beyond, and you can say, oh, yep, I know where that came from. And it's such a simple formula. I've just shown you like one simple formula. And you can pretty much figure out what the wavelength will be, where the nodes and antinodes will exist on your instrument. That will tell you that you now need to retune it.